Hi, so let's look at another example under triple integrals in cylindrical coordinates. Okay, so this question that we have here is also pretty interesting and straightforward. So let's go ahead and do the integration and evaluation. Okay, so the outside integral is this is from -1 to 1. Then on this part we have from 0 to 2 pi. Okay, so if you integrate this with respect to r, okay, it's more like you have your 4r, then there's a 1 here, you add the 1, then you say 1 plus 1. So this is going to be 4r to the power 2 divided by 2, which is just going to be 2r squared. So this is going to be 2, then I'll put r squared there, then I evaluate from 0 to 1 plus cos theta. So I'm remaining with d theta dz. Okay, so again, just a reminder, cylindrical coordinates is a combination of polar coordinates and rectangular coordinates. So it's like you have the z that has remained from cylindrical, then you have the theta and the r that has come from the polar. So yeah, so what does this evaluate to? So if we plug in uh, if you plug in 0 there, it's going to be 0, but the upper limit is going to we are going to have something there. So let me just write it on the bottom here. So this will be like -1 to 1, then from 0 to 2 pi, like that. Okay, so I say 2 here, then I'll say I'll put brackets, then I'll say 1 plus cos theta squared. Okay, cos theta squared, then you have your d theta dz. Okay, so you can go ahead and expand this, which is pretty simple. So it's like you have your 1 plus cos theta multiplied by 1 plus cos theta. This is just going to be like 1 plus 2 cos theta plus cos squared theta. Okay, so that's what is this is going to be equals to. So we have that from 0 to 2 pi, and remember to say we have a 2 outside, so like we have something like that, then we have a 2 outside, so this is going to be like 2 plus um, then this is going to be a 4 cos theta, then plus 2 cos squared theta, then here you have your d theta dz. Okay, so you can try to do some simplifications here. Okay, let me just erase for this part. So for this one, integrating this and that is pretty simple. Okay, but when you think of cos squared, you might end up thinking to say maybe I need to use a reduction formula. Yeah, it can work, but it's going to consume a lot of time and maybe even space. So what you can do here is just to use one of the trigger identities. Keep in mind to say uh, there are some there's a trigger identities where we have cos squared theta, which can be written as 1 plus cos 2 theta divide by 2. So you can just bring it here and substitute. So this is going to be let me just write it here. We have the 2, which is this one here. Then instead of cos squared, I'm going to write 1 plus cos 2 theta divide by 2. So this can cancel out and that can cancel out, so meaning this one can be written in place of that one, and it's going to be like this. I'm going to get this one and add to this 2 here. It's going to be a 3. Okay, this is going to be a 3 plus 4 cos 4 cos theta plus cos 2 theta d theta dz. Okay, that's what we have. So what does this give us? So we can now do the integration. Okay, so if we are to integrate this from -1 to 1, so integrating this with respect to theta, this is going to be 3 theta plus the integral of cos is simply sine, so this is going to be 4 sine theta plus this is going to be uh, sine 2 theta divided by 2. Then remember we are evaluating from 0 to 2 pi remain with you, your dz there. So you observe to say if you plug in 0 or 2 theta itself, when it comes to this part you get a 0, because sine 2 theta um, sine 2 theta for this one is 0. Even sine 0 is 0. Here if you plug in 0, that's still a 0. If you plug in 2 pi, uh, if you plug in 2 pi there, that's going to be like 2 multiplied by 2 pi, that's like 4 pi. That's it's more like you are saying 360. Okay, 360 divided by, sorry, 360 multiplied by 2, which is 720, which is still going to give you a 0. So meaning you just have to evaluate for this one here. Okay, so what is it going to give you? Let me just erase this part. Okay, so if where there's 3 theta, where there's theta in the 3 theta, you plug in 2 pi, that's going to give you 6 pi. Then you have your dz there like that. Okay, then let's go ahead and determine the final solution. So if you integrate 6 pi with respect to z, you're going to get 6 pi z. Of course, this one is supposed to be evaluated from -1 to 1. So this would be like 6 pi, then open bracket, you say 1 minus, open bracket, minus 1, like that. So this will be 6 pi multiplied by 2, giving you 12 pi. Okay, so the answer for this question is simply 12 pi. And that's how we do it. So yeah, I think I'll end this video here. For other questions I'll have to make separate videos. I don't want the videos to be too long. Yeah, thank you very much for watching.